Laminar versus turbulent flow. This video was created by Maria,
Anastasia,
Shada.
Souls.
In this video, we are going to talk and demonstrate the difference between laminar and turbulent flow. These flows behave in very different ways. In laminar flow, the particles of the fluid travel in a straight line or parallel layers. There is no mixing and the velocity is zero on the walls. The maximum velocity is in the center of the pipe, and the velocity profile is parabolic. In turbulent flow, the particles no longer stay in a straight line. They are moving in 3 dimensions around the pipe in a chaotic movement, creating eddies. As the particles of the fluid experience a whole range of velocities, this will average out the velocity profile. We will still have zero velocities at the walls, but now the velocity profile is more uniform and flat. What affects whether the flow is going to be turbulent or laminar? There are 4 different variables: velocity, viscosity, density, and the shape or diameter of the pipe. Velocity is how fast the flow is moving. Viscosity is a measurement of the fluid's resistance to flow. And density is the mass per volume of the fluid. All of these variables are combined into what is called the Reynolds number, which can then be used to tell whether the fluid is laminar or turbulent. The Reynolds number is dimensionless, which means that the dimensions of all the variables cancel out. As you can see, mass will cancel out first, then time, and finally length. If the Reynolds number is less than 2,000, then the flow would be considered laminar. If the Reynolds number is greater than 3,500, then the flow would be considered turbulent. Here is an easy way to see how laminar flow changes to turbulent as the velocity increases. Even though the density, viscosity, and the size of the faucet stay the same, as we open it more, the velocity of the water increases, changing flow from laminar to turbulent. In the first experiment, we add food coloring to corn syrup. When we move the inner wall, it causes friction between the wall and the fluid. Since the corn syrup has high viscosity, it will move in a laminar flow, which produces parallel layers. This can be seen by the layers of the colors. We did the same experiment using water, which is less viscous and has a lower density. All the colors will end up mixing together and no layers are formed. Thank you so much for watching.